Okay, it is, I guess it's 9:30
Correct.
at the local time. Okay, it's 1:30 in the morning in California. So welcome everyone, no matter where you are. Thank you for coming. So good morning, good afternoon, and good evening. And hope you've been enjoying the IETF week in London. This is the Reliable and Available Wireless, or RAW, working group. And I'm Eve Schuler, and I'm remote in California. And Rick is in the room.
I am here. So, yeah, let's kick off. Let's make the slides work.
Okay.
Why is slide two? Oh, there we go. So, as with every IETF meeting, this meeting is covered by the note well. If this is your first session, given it's Friday, that's I hope unlikely, or your first IETF and you haven't had a chance to read this. The note well covers the IPR, your participation in meetings. That's a bit of feedback. Please be aware that anything you state at the microphone, place onto the mailing list, or comment in general is covered under the IPR regulations of the IETF, and you have agreed by that. If you are unaware of any of this, please check the relevant BCPs, which we normally call out, I think, on the next page.
Yes, on the next page. There you go.
Yeah, on the next page. So here is a list of various BCPs, which should introduce you to the Internet Standards process and the processes of working groups. Talk about about copyrights, patents, and participation rules. But also, I will draw attention to the anti-harassment procedures, and code of conduct. Although we promote vigorous debate, bullying and unacceptable behavior is obviously unacceptable, and there is a process to address this. So if you feel that behavior becomes out of hand, please let the chairs know. It's our responsibility to prevent that from happening, and there is a proper, well thought out formal process to handle it. Just to draw your attention to it. Beg your pardon. So, a little bit of administrivia, because this is a joint remote and in-person meeting, and I must say it is very nice to see so many people in person. This is feeling like an old-fashioned IETF again, which I'm so sorry, Eve, there's a really nice buzz here and you're missing it.
Someday.
For in-person participants, because we're going to use a shared queue for the mics, please make sure you use the little app on your phone or click the join the queue button on your laptop, so that remote participants can also join the queue fairly, so we don't have two queues. As ever, if you're speaking, please state your name first. It's just useful for the note takers. Mask wearing, yeah, mask in the room, please. It's policy. Unless you are actively speaking at the microphone, I count myself as actively speaking at the moment. Also, to avoid feedback, can you mute your laptop audio, particularly if you're remote, to save on feedback? Headphones strongly recommended if you are at home. Yeah, that's it. So we will be using the integrated Meet Echo interactive markdown for minutes. This is a collaborative tool. I don't believe we have an official minute taker, so please, either if you want to take copious minutes, please attack right now. But more importantly, if you want to make a point and you don't believe it's being caught, or your name is not being captured spelt correctly, please get into that online minutes and make sure that's properly recorded. The problem with collaboration is everyone assumes everyone else is going to collaborate rather than you, and then we don't capture the minutes correctly. So it's a sort of group responsibility to make sure we've got some proper minutes taken. The meeting materials, I'm assuming by the fact you can see these slides, you can get to this URL, so it's a bit of a recursive problem, but all the meeting materials are available through the data tracker and through the nice Meet Echo integration. And as ever, we are an IETF working group, which means we have a mailing list, which is raw@ietf.org. I hope you are all subscribed. That is the best place to have long and lengthy discussions. And if you need to contact the chairs for admin purposes, there is a RAW-chairs mailing list to be used for administrative purposes, not for topics of content discussion. And there's the
Oops.
Meetecho crashed. Meetecho's come back again. Right. We've had some networking issues this week. Is it recovering?
Yes. Oops, maybe not. Shall I give it a
Let
shot from over here?
Let me find the slides again. Oh, cool. Yep. Sorry. Small technical details. We do not apparently have reliable and available wireless in the room. So Eve, do you want to go through the document status? Otherwise, it's just me talking.
Sure. So for those of you who may not be tracking on the mailing list, the status of things, we are very close due to the hard work of the authors and our AD, John Scudder. The LDAX document is on the brink of being completely ready. It's the last of the discuss status of various ADs and reviewers have now been converted to abstains. I believe John is wanting to give it one last very detailed read. So we may be within the next week or two having the LDAX document advance through the RFC process. So we're very excited about that. And again, thanks to the hard work of all the folks involved. Let me just see if I'll share the deck. It went away again.
Yeah, Eve, you share. I don't
let
want
me just see if I can get that up over at this end. Can you see that in the room?
Yeah, we can see that.
Okay, here you go. So, and the use cases draft has similarly begun to progress through the IESG and has received, a routing review, and it's been through the TSV, so the transport and GenArt reviews as well. And thanks to, I believe, is it Karina who is the shepherd for this? We are now at a rev of the document. I think it's 8, having incorporated all of the feedback from the 3 reviews so far. We still have quite a few that we await. Then the technologies draft has begun that journey. And so Carlos Bernardos has, solicited the feedback from the authors on IPR. So at least at this moment in time, we haven't gotten any, there's nothing eventful happening on the IPR front. I mean, no one has anything to declare there. But in the meantime, we've had a funny expiration of the draft. But I think once things open up again, it will be resubmitted. There was also some interesting activity on the 3GPP front in the SAT.
Eve, can I interrupt you because Carlos is at the mic? Just to.
Hello. Sorry, I was just looking at the document. I was not looking at the mic. Go ahead, Carlos.
Hi, Carlos Bernardos, UC Dreams. Just to basically apologize for not taking or not progressing on the shepherding for that document. I started. I expect to have the write-up in the next 1 or 2 weeks while the IPR declarations are made. So I just wanted to update a bit on that and apologize for taking a bit longer than it should have been taken. So.
Thanks, Carlos.
No worries. We are greatly appreciative of you taking on the shepherding. And
we have Pascal in the queue as well, Eve, sorry.
Oh, go for it. I'm looking in the wrong places. I don't have enough windows here. Hi, Pascal.
Does it not pop up in the corner of your screen?
No, it is. I was on the wrong view at where I am, so I wasn't seeing the...
Go ahead,
Yes,
Pascal.
just for Carlos, since you have to indicate the number, I owe Janosch to publish a slight update of the technology draft because of the new references that Janosch has provided, and probably that's what Yves is alluding to as well. So I will publish like next week a rev. So yeah.
Perfect. And for those of you who may not know, there was a DetNet study group in the 3GPP SA2 group, and so they have a new publication, and so there's some slight wording updates regarding the recommendations there that once things open up, Pascal will resubmit on. And then life goes on with regards to the other documents. We'll hear a lot today about the architecture document. The framework document is a little bit off into the future. OAM is progressing. We do need to understand what's happening with our industrial requirements document. Our last correspondence was that there was going to be a new rev, but we need to close on that. And then, of course, there are 3 documents. I think they're all Carlos's. At least he's a co-author on them that are under consideration for working group adoption. Have I missed anything?
If I'm correct, Yves, Carlos has published personal drafts because they're interesting, but I'm not sure you asked for working group adoption. I think you said
no, we have not.
Do a bit more work on this, so it's not really for consideration of the working group as work, but certainly of interest to the working group. Is that right? Carlos is at the mic.
Yes, Carlos Bernardo. Basically, I was waiting a bit for the working group to be done with the other actual milestones to then ask to the working group if this may be considered as something interesting. So I will be waiting until the other things are out of the line.
Thank you. I think that makes a lot of sense.
Okay. Oh, right. I'm controlling the slides.
You have the slides.
The thing that the sleepy person in the room or the virtual room needs to remember is to advance the slides. And so our agenda today is really to focus and give time to the architecture draft. And Pascal has done a tremendous amount of work on it with his co-authors, and there's been lots of discussion both on and off the list, and he will be giving us a very detailed update on that. Rick.
So I'll jump in at this point. So I'm conscious that we have a good sized session today, and the architecture draft is it's getting a lot of review, it's getting a lot of comment, and it's slightly blocking our work. So really, what I would like to see is us really tackle the architecture draft, almost workshop it. We have the time, we have relevant people in the room, and to as a precursor to this, Pascal, Lou, Balash, and John Scudder and Janosch and myself had a pre-meeting to talk about how can we make progress? What are the main sticking points here? Are they insurmountable? Can we make progress, or have we got a problem here? And the answer was actually we didn't have a problem. We could make progress. But the recommendation in fact, the decision by the chairs, and thank you, Pascal, for letting us make that decision, was given the architecture document actually introduces 2 new concepts. One very much about how does RAW make deterministic forwarding plane decisions, and a separate novel piece of work, which is a new kind of service function or forwarding plane protection function, which is the pareo function. By introducing both of these new pieces of work within one document, firstly, the document got big, and the bigger the document, the harder it is to review and the harder it is to maintain readability, etc., as we all are well aware. And secondly, we felt as chairs that the introduction of the new forwarding plane control ability and that fast feedback loop around PSE was the architectural piece, and the pareo piece could be introduced in parallel at a slightly slower rate. So we can have an architecture document without having to get the details of Pareo correct in one big bang, we should just split the document in half. And that means we would have a lighter architecture document that would talk about PSE and make sure it was a good quality document that framed, I beg your pardon, that framed what RAW was hoping to achieve. And then we could take time to get Pareo nicely described, have good quality discussion and review and so on. The complication when splitting a very large document is there is now quite a large group of contributors. And it is always difficult trying to attribute the right text to the right people, particularly when there have been many revisions and many contributions, some which may have not survived the different revisions. And so as chairs, we took the often unpopular decision to say, both of these documents will now have one editor. All contributors will be placed in the acknowledgements section and acknowledged as key contributors to the document, but there will now be an editor rather than a set of authors of both of these documents. I will say the chairs and the AD are very happy to discuss that decision to make sure people understand that the authors understand that clearly, but we'll take that offline. That isn't really a matter for the working group. It's a matter for the chairs. Given we are moving to there is an editor and a group of, and the working group contributes to it model, you have to name that editor. As Pascal has been carrying the editorial pen at least over the last couple of revisions, and he's happy to do so, we wish to make Pascal the editor of these documents. Again, if you feel that is contentious and you have any complaint about it, please talk to the chairs and the AD and we will get this resolved in some way. As far as the working group is concerned, I believe this decision will help us make progress on raw architecture and let us do proper review and consideration on Pareo and unblock some of the work, as Carlos alluded to, which is sat in the backlog waiting for adoption or for those of us to find review time to look at when we have a nice architecture document we're really happy with that can frame our decisions and our reviews. Would anyone, Carlos is at the mic, go for it.
Thanks, Carlos Bernardo. I don't have any issue with the decision. I'm perfectly fine. I think it's the right one to keep Pascal as editor of the documents. I had just a clarification question. So is this a split meant to be like one document will be like taking care of how the raw architecture entangles with the DevNet and ensure that everything is coordinated, while the other one will basically take care of the very much wireless specifics, and in this way kind of facilitate the integration? I mean, because you mentioned the Pareo and the optimized functions will be in the new work document. To me, that's fine. And then the interaction with the OEM generates .NET will be in the other one. To me, that would make sense, but I don't know if I understood properly the idea behind.
Yes, I believe you have understood correctly. You said one thing there which I would qualify, which is the architecture document is, you said less wireless focused. I would disagree there, because I would say in that architecture document, we still talk about the fast feedback loop with the OEM plane, because wireless moves much faster than in general wired networks. And so we have that faster feedback loop and that PSE concept, which I would suggest is very much wireless focused. You know, these are wireless adaptations, but then the details of the protection function, Pareo specifically wireless optimized protection function, makes more sense in a separate drop.
Yeah, I agree. I expressed myself not very clearly.
No, it's
of course, the PSE is the key architecture component enabling this, and this is in the first document. I mean that then the specific function that this component may do to do these things is in the other one.
Yeah. Okay. Thank you. I'm going to pause here if anyone else has any comment on this decision. This is a good moment to air concerns if you have any. Otherwise, Carlos is still in the queue. No, he's gone. Otherwise, we'll move on. What's the next slide? I think we're going to get straight into the guts of it, aren't we? Yeah. So, Pascal, you have plenty of time. Let's.
Okay, so apparently I'm entitled to take this off. I'm the lucky guy in this room. Okay.
Let me. Oh, there we go. That's probably not going to work for my laptop, so shame. Forward and back.
Do you want me to try?
Try it. It's not paired with my machine, and I'm showing the slides, so I don't think it's going to work.
Oh yeah. On paper, it would not work. Okay. Well, next slide, please. Okay, so I will start with the draft, with the slides I prepared before the meeting, knowing that with the recent discussion, some of that is partly resolved or appears to be on good way of resolution to be agreed with the group. And so we'll see where we are for which those slides might be slightly obsolete. So what happened recently is a lot of great reviews, I mean, a lot of exchanges with Lou, Janos, Balázs, and I thank you all for the time you spent on reading the document and considering it, and etc. Part of the results is Lou is added as a contributor to the document, and Balázs is strongly acknowledged. I don't remember if it is on the published version, but you are certainly in the acknowledgement, Balázs. And then there were Lou comments about Pareo that still needed to be discussed, and with the decision that the chairs made, those comments now will apply to a separate document, and so they will be made separately, and they are not blocking the architecture document anymore. We did a lot of restructuring to help the new readers, because we're all used to what we are saying, but the new reader may want something more serial, so we reorganized a bit. The introduction got simpler, and based on the comment by Lou of what is raw exactly, we extracted a new section 3. Also, the term OODA appeared many times, that it was a fundamentally new thing. OODA has been there for like 50 plus years. And the fact that it respects the OODA model is not the fundamental thing. The fundamental thing is we have this fast control loop. OODA is a model for control loop, is the model that we are following, but it's a control loop. So we renamed the section raw control loop to insist it is a control loop, as opposed to insisting that it's following the OODA model. Right. There was also this point, I mean, it's my French here, where I said something like raw versus .NET in one section title, and for me it meant nothing. But apparently in English, there is a sense to that. And I really made, how do you compare this and that? That was the meaning. But this versus that appears to be a conflict. Certainly, raw and .NET don't conflict. The goal is that, we are providing a plugin functionality into .NET. And so it cannot conflict. It has to smoothly integrate. So certainly the title gave the wrong impression. Sorry for my French. So yes, we clarified that raw is a specialized enhancement that mostly applies to wireless, but since we are layer 3, it could apply anywhere. But the needs really appeared in the context of wireless and wireless mesh. Next slide, please. A number of issues that we discussed. There was one, and probably it's again my French or the way I express things, but seemed that the text could be read as if we were changing something on wireless. We are not touching wireless. That would be a layer violation. The best we can do is provide hints to the lower layer about the sort of thing we would like to see achieved. And we currently don't have even the APIs for doing this, but the architecture should show that we expect that someday we might have something and we need to position it. And that something is basically some capability to hint the lower layers of the sort of result that we would like to see. An example of result is if you send something on Wi-Fi today, you'll get by default 64 retries, which could take forever. In RAW, that doesn't make any sense because we have a bounded latency. So at some point we need to tell, hey, Mr. Wi-Fi, I know you're doing your best, but if you don't send that within that bounded latency, drop it. Or, hey, if you can, please do at least a few retries. I don't know how you're doing that, that's layer 2, but try to make the reliability of this packet a factor 5. I don't know how to express that, but make it more reliable than this other packet. By doing more retries, doing retries faster, I don't know, the way you do it. Okay, so conceptually, the architecture should represent that service access point, basically, between layer 3 and lower layer, where we can express more than just here is a packet, do your stuff. Okay? It might be that this interface could be useful for wires as well, because at some point, if we don't have a time-based shaper and we have something like an asynchronous shaper, it might be that we want to provide the lower layer with a bounded latency as well. So yes, we clarify that we are the architecture layer, so what we are doing is conceptual, but we are basically adding new services. And they are considered and meant to apply at least to the technologies that we support, we have in our charter, and they're listed in the raw technology. There is this problem of one hop, which could be solved at layer 2, and multi-hop, which is what we do at layer 3. And certainly we already have a lot of work and capabilities for getting information from the lower layer, and then we use that in routing. We compute, we have RSSI, we have LQI, we can do ETX, and there are tons of things we can do. We've got DLEAP, and we want to build on all this. And at the same time, we need to do it over multi-hop. So we need to differentiate those concepts and see how they work together. And that's part of what the architecture must represent. And then there was this question, and for me it was coming from the blue, but one of the pareo functions is overhearing, meaning that one sends, and you know, by the magic of the radio transmission, there will be multiple receivers. And again, it's probably my French, I must have written it such a way that it looks, oh, it's completely new to radios. And obviously, yellow wires were like that, so it's not like it's completely new to radios. If you configure a switch with promiscuous mode on one port, that port will get all the packets. Mostly we do it for tracing, not for forwarding. But that exists. You could even, and Lou mentioned it, you could even have an underlay, which is a multicast to send your unicast packet. I've never seen that. I don't know why we should do it, but it's feasible. So yes, overhearing could happen at a cost. It just happened that for wireless, yes, one transmission from A to B is lossy compared to wires, but there are ways which are other properties of the same medium by which this disadvantage can be compensated. And it comes from the same magic that causes the loss, is that others can listen to it. Can we do something to compensate the fact that one point-to-point radio abstraction is lossy with the fact that, in fact, physically speaking, it is a point-to-multipoint thing? And that's really what we want to discuss with this promiscuous overhearing thing. We want to say, hey, yes, your receive ratio drops if you consider the link as point-to-point like we would on wires, typically. But on the other hand, there is a 0.4 ratio on the other guy here that we could exploit because he got it. If we consider that in the overall routing, hey, maybe the loss here is compensated by the received there. And RAW is a lot about doing that. And one of the methods effectively that we can leverage is this overhearing thing. So we insist that it's something that, yes, it was always there. It's not the question. The question is here we intend to really use it and build on it and consider that it exists and include it in our routing thinking so that if the packet is received by the wrong guy and the wrong guy is on the right path, yeah, the packet can continue. See, that's part of RAW. Next slide, please. Okay, so when I said that some of those slides, and that's basically a third of them, is probably obsolete by now, this is it. So we need to discuss pareo. We need to go into the details of how it works, what it does. Whether it's new or not is not so relevant. More relevant is how we're going to use it, how we're going to abstract it, how we're going to talk to the lower layers to get them to do things for us, because we don't do it for the most piece by ourselves at layer 3. but it's another document. So this document is supposed to give the big picture. So we had this tension. It's not on the slide, but I realized we had this tension with Lou about, and Lou, I mean, you know, you're free to come to the mic anytime if I'm not misspeaking, but we had this tension where I had the intention that this architecture is the big picture. I did not focus so much on what's new, what's not new. I focused on here is how it works, right? Here is the map of London. And if the London Bridge has been there for 200 years, it's still on the map. It's still a fundamental component of this architecture. Whereas another reader could say, hey, all those things, I know them well. I just want this document to focus on exactly what's new. Well, if I just give you what's new, you don't have the map of the city, you just have the shard, right? So there is this tension about, you know, wasting time of the reader by saying something he already knows and he has seen everywhere. And the fact that you still need to provide the map of the city. So that's something we have to arbitrate. But personally, I'm happy with the current content of the document. I would not like to strip it too much. So I focus really only on the very new things. I want to show how the components are integrated together, the new and the old. And then there was this track segment, T path, and I still need Lou's help on exactly crafting the words, but we inherit from two worlds, like this Java class, which will inherit from two interfaces, and there might be collisions. And effectively, we've got collisions. In the small, tiny IoT groups, we have agreed that the term path was so overused, overloaded, that it lost a lot of its significance. And we kind of, when we talk about path, we end up not really figuring out what the guy is talking about. So for the thing that we built, for radio, multipath, etc., we crafted this term of track. And so as I'm coming from that world, I've been using it and using it and using it. It is in the 6-dish architecture, it is in the role documents, it is everywhere. And if you look at it, it does not represent a path as most of us are used to call a path. A path in the path research, working groups and stuff, is an observable thing. It is the result of a packet going through a network. The path is where this packet has been to go from A to B. It is a consequence. It is an observable. I have listed in the document the quote, because if I don't speak it correctly, at least the quote is in the architecture. Now, if you go to other documents, you will see other definitions of path, and they got more and more wide and more elastic. And then Lou understands the definitions that are done in T's, etc. But my concern was, path is supposed to be an actual thing. It's supposed to be where the packet's going to be, and it's observable, it's measurable. You know where it's going to be. Just like my example for that is the moon around the Earth, which has an orbit. You know where the moon is, you know where it's going to be. And if there is something which should cause the moon to change its track, like we send this big bomb on the moon to make it change, like in Cosmos 99, for those who have seen that, it's still predictable. We'll know, we'll control, we'll know we're going to do that. We'll throw that rocket at the moon, it will change its orbit, and we'll know the new orbit. Now, a track is not like that. The track is the aggregate of all the possible places the packet can be. But at any point of time, you don't know where it is. The packet can be network coded, meaning that it's turned into smaller chunks which are sent on different paths. There is not one place where the packet is. Okay, and because of the PSC activity for this packet and maybe a few packets, it's going to be a subset of all those hops which are going to be used for this packet. It's not the whole track. The whole story of what we are doing here is to not use the full track, but always use a subset of it that is enough to get 2.5 copies of your packet to the end. But it's never the same. Until you stop the system and observe one packet, you never know what the packets will be. So that's why I like this quantum thing, this quantum analogy, because the track is to an orbit what an orbital is, for electrons. The electronic orbital is a statistical representation of where, quote unquote, the electron can be. But unless you stop the system to observe it, you will never know where the electron is. And in fact, with Heisenberg, even if you stop the system, you don't know. But the analogy is there. The analogy is the track represents a statistical aggregate of possibilities, where a path is the observable result of a packet that has been flowing through the network. And if we use the same term, I was concerned, that's why I had all that discussion, that the term path now is even more abstract and people less and less understand what they're talking about. So I was all for a special term. Now, Lou told me yesterday that maybe there is the term DetNet path or something that is in the DetNet documents that we could use. The bottom line is we kind of agreed that the terminology must provide all the terms and provide the synonyms and kind of explain that this actually comes from different places but means the same thing as that, kind of. So I tried to craft that, and I hope Lou will help me do that terminology. Then we'll have to, the thing which will be hard on me, but I probably have to do it, is going through the text and see every time I use the term track and change it to this new thing which comes from the T's world. It's less familiar for me. All of a sudden, I feel that I don't master what I'm talking about anymore. But
so can I jump in at this point? I am in the queue as well as kind of with my chair hat on. As I see it, RAW has a very close relationship with DetNet. We are very much a sibling group of DetNet. So I think there is relevance in making sure the terminology we use in our documents maps very closely to the terminology used in DetNet. So a DetNet, someone in the world of deterministic networking can understand what DetNet does and what RAW does using the same terminology. I absolutely understand the point of, within the wireless world, completely different terms are used for things which may or may be close to terms used in the DetNet world. So I absolutely agree with the suggestion that some kind of glossary to make sure that there is a mapping between the different terminology universes out there. But I would suggest strongly that the main terms that are used are the DetNet terms. So that cues up Lou, who is behind me in the queue, and I would like you to step to the queue. This track concept, because I'm very happy for the session to be quite workshoppy here, what is the corresponding DetNet term that we should be using instead of track? Or do we need to define, and I actually don't care what the word is, do we need to define this potential total transit across this orbital? Go.
So what is a track? I'm being serious. What's a track? Give us a tight definition of a track.
a track is defined in the architecture. If we could read it to make sure we have all the words, it's crafted. I spent time on it. But it's basically the collection of hops on which the packet may pass, depending on what the PSC decides to try, and the radio accepts to forward.
So in IETF traffic engineering, we call that a path.
The path
In IETF traffic engineering, I'm not talking about, PAN research group. I'm not talking about other research groups. I'm talking about in the context of traffic engineering. That's called a path.
I understand that, and you gave me links, and I read those links. And I was not convinced that we are talking about the same thing, because when I looked at the text on path, it still indicated something which was kind of deterministic, where the track is statistical. In terms of operation, I mean, once you configure your track, your path to work like this, even if it does replication, not replication, you kind of say, do this. It's not from a local loop or anything that is kind of hidden inside the system, but it's something which is really controlled by the outside. Then for a long time, quote unquote, in those orders of magnitudes, it's just a matter of orders of magnitude and time. But for a long period of time, which is observable by the PC, etc., the network behavior will be exactly that. And then you can decide for whatever reasons, mostly reliability, to change that, and then there will be an action that's visible, that's from the outside. And so the path is always very well known at each point of time. It's completely controlled. Do I misunderstand?
So in the context of IETF traffic engineering, a service may be supported by many paths. They're often called primary or secondary or protection or alternate. And the actual path that is used, and that may be one or more, is based on the protection switching function that's being used.
Yeah.
So we've had 1+1 protection, of which pre-auth and DetNet is a new type of packet 1+1. We've had 1 for N protection, and for various technologies, to me, Paro sounds like a new 1 for N protection scheme that is being used, being defined for wireless, and maybe it's not 1 for N, maybe it's 1 plus or for N, because sometimes you might use multiple, sometimes you might use 1.
That's what I mean by orbital.
I'd prefer to stick to terms that we've used in the IETF. And really, you know, we're operating within the context of IETF traffic engineering, from T's that's further down scope to DetNet, which is further down scope to RAW. So it would be good if, as we sort of
Understand.
Populate up in terminology, that we inherit terminology from the groups that we are inheriting technology.
I understand that desire, but at the same time, I understand it. I'm all for it. Conceptually, I'm completely all for it. I'm discussing because each time groups like traffic engineering have taken the same term as before and extending its meaning, the sense of that word has started to become more and more fluid or something. And so two people, unless they really speak within the same context, start not talking about the same thing, and they don't even realize it. That's the danger of overloading terms.
Sure.
And here I have the sense that we make a small step overloading path yet a little more. Because in my view, I mean, I want to use T's, I want to do it anyway. There is one desire I have to change, and you would not even need to ask, is for everything I called a subtrack, which is a definitely well-organized subset of the track. I wanted to call it a T path, or use your words, I mean a path. Because that piece is deterministic, it's well-organized, it's exactly that. Now, the track is the collection of them, or the set of all the overlapping paths. So I expect the PCE to design 5, 6, 7, 10 paths and place them in the same set, which has all the links of all those paths, if you like. So the links are the track. And the PSC selects out of that subset, which is the track, on which we do OAM and all those games all the time, regardless of whether we use them or not. The PSC selects a path inside that set. The track is the set, the path is what the PSC selects at one point of time. That's my intention. So I have this term subtract that I'm very, very happy to remove, because it's effectively, in my mind, matching what you defined. And for the exact reasons you say, I want to do that change. Now, for the track itself, which is the set of all those things, the coalescence of all those T paths, I think it's a little more. We are stretching the term, and I don't like to stretch the term even more. Mostly because at the end, one is a set, and the other one is a T path, as you define it.
I'd really like to go find an old CCamp presentation. So CCamp was created, well, no, it is when it was rechartered, when T's broke off. It was, its scope was set to help new technologies reuse IETF traffic engineering techniques, terminology, solutions. And that old presentation talked about how it's very common for someone who has a new technology to show up, spend a whole bunch of time adapting to what they think and saying, okay, we're ready to go. This is our this is our solution. It's time for an RFC. And then to enter the CCamp group. And that's the start of what CCamp does, is help take what is this unique technology. Well, from the perspective of those people who are coming in with a new technology, here's a unique solution, and saying how much of this solution is actually unique and how much is generic. And part of the process is teasing out the terminology to get the terminology aligned with what's already there with IETF traffic engineering. And then by getting the terminology right, you help identify which mechanisms exist and can be used, which mechanisms are brand new. We are in that process. Now, we're not quite at the very beginning. The working group's been running a little while, but I don't think we've had that good synchronization. And we might benefit from talking to the CCAMP chairs and that CCAMP working group, and maybe even doing like a joint interim and say, help us, merge our now well-formed architecture document into IETF traffic engineering. So we're repeating a process that we've seen many times for many different technologies. By the way, microwave was one of them. It's a wireless technology that is point to point, so you don't have overhearing. So it has different characteristics than what you want, but it's still wireless. So they've been down this path before. I think we would benefit by trying to work more closely with them.
I mean, I completely buy that. It seems to me orthogonal to the fact that there's still this question whether the track, as I figure it, is within what DetNet calls a path, or if it's just the subtrack that's being selected, which is what DetNet calls a path.
So from a DetNet perspective, we have something called a service. The service may be supported by a set of forwarding layer paths.
Agree with that.
And that there could be a protection function that maps the service to those paths. I see nothing here that you're describing as being different from that.
And there is.
I'm jumping in the queue. No, I'm going to join the queue.
So Balash. But I need to cue your question because it's all turning around the same problem. So you want to speak first?
No. Balash, go ahead.
Yes, Balash is.
Balash Jorge from Ericsson. I have two comments. The first, I have really déjà vu. Sorry for my French. When we started in the DetNet work group, TSM work were already done in IEEE. And we had exactly a very similar discussion those days because TSM already had the terminology. In DetNet, this was, okay, in DetNet, we have not yet had the IETF terminology for all this stuff. So there were lengthy discussion and similar methods like Lou proposed. With DetNet, we had the luxury that having the TSN guys also in the room during the discussion. And we have made that happen in the architecture document. So there you can find also some IEEE technology and terminology. And it is pointed exactly what is DetNet terminology relation to those terminologies. So something similar here, I think would be excellent to have. The second comment is about this track story. So I think in the document, you have also complex path. And when I have read the document,
yes, I need to
my understanding was that it is describing your track terminology. And then we have a terminology with path, which is describing what you wanted to have with that. And also regarding the flows, we have defined in DetNet the member flow and the compound flow, which is, of course, on flow level, but something very much related to what route, just not to use track or path, what route to take over the network for the packets belonging to a flow.
I can answer the second one first, if you don't mind. I think there is a bug in DetNet. I tried to raise it a number of times. And the bug in DetNet is that there is a huge confusion between the water and the pipe. The flow is the water. That's what goes from A to B. The pipe is quote unquote all this path discussion. It's where it's gonna go, what's gonna happen to the packets on flight, etc. The flow is in DetNet typically not the compound flow. The base flow is identified by the 5 tuples, meaning it is a application layer construct. The application decides what goes in a flow. At some point there is, and it's written like this in the architecture, I know because I wrote it, that says at some point the flow is mapped to a path. And that's intentional. The intention is to say there is a function somewhere that we decide that this water goes in that pipe. And the cool thing about separating the water and the pipe is that you can, for instance, decide that this OAM goes in the same pipe, will have the same treatment as this water. So all of a sudden, the OAM can observe the water. If we do things based on application signaling like the 5 tuples, we're screwed. All of a sudden, we have all those problems. Hey, how shall we put my OAM on the same forwarding operation? You can't, because you made that mistake of signaling stuff with the application. I mean, it's not your stuff. That belongs to the application. That's a bug. So I went to the mic several times, tried to say, hey, we confused the water and the pipe. I wrote this IPv6, .NET over IPv6 document, which I'm not maintaining, but when the group is finally interested in doing that, I will be happy to revive it, where I write this down in words, and I show how IPv6 can signal not the flow, because that's already what the application did in the packet, but how you process it in the network, which is the pipe. So don't tell me, don't do what you do because we have this bug and I want you to emulate this bug. It is a bug.
I don't see it in that way, because
Yeah,
at the edge node, at the edge of the .NET domain, you are just doing the .NET flow identification. So it is not an application related signaling. This is something that you are deciding at the edge of the .NET node, and within the .NET domain, you are using those credentials to identify the flow. It is not driven by the application.
As soon as you decouple the treatment of the packet from the 5 tuple, you fix my bug. As long as we relate what .NET does, I'm not talking about the ingress function that puts the data in, I mean, that exists. But once we have decided that this thing goes in that pipe, we should not be looking at the application information anymore. We should signal our own pipes. And if we put multiple pipes in a bigger pipe, we just signal that. It's our own domain. We can decide how we signal it. And now the compound flow is just a pipe inside another pipe. Right? So there is this first function that assigns the application layer stream to a pipe. And then we are in our world. And that's what we need. That's how we need to build. That's an architecture. And the .NET architecture is worded like this.
But this is exactly what the flow identification functionality do at the edge node.
Yes, the flow identification will have some mapping table of sort, which will do several things. Recognize the application flow. If it's tagged by 5 tuple, it's tagged by 5 tuple. It will assign a path. It will do some shaping if the flow doesn't respect the shape of the pipe, because we insert that flow in that pipe, the shaping must be correct. So there are all those things which happen at the ingress edge. And once that is done, we should not see, look, observe, think about any application layer signaling. We are in our world. And I don't think the .NET specifications are clear enough on that. But at least my IPv6 hop by hop document is very clear on that.
Okay, let's have further discussion on that. Maybe just one final comment is that in .NET we have 2 data plane. Not only IPv6, we have also MPLS data plane.
Yeah.
So,
but in MPLS, I'm sure that naturally you fix this bug because you label inside label inside label. So very soon you're in your own labels.
exactly.
And so by nature, even without thinking about it or wording it, you kind of solve that problem. But still, a lot of the discussion I'm hearing and all these things about 5 tuples and all lead to the impression that we have this bug. And I want to be very, very clear in everything I write that I'm not writing for that.
Okay.
John Scudder, Juniper Networks. So I somewhat regretfully want to return to the previous conversation you were having with Lou, which made me think a little bit of Alice in Wonderland, and a word is exactly what I mean it. Use it to mean neither more nor less. And I still feel like a new guy in this group, and like I kind of walked into the living room when the conversation is well underway. So, forgive me as I continue to come up to speed, but it sounded to me, listening to you guys converse, like you're saying, I really want to not reuse your words when they have a different shade of meaning from what I mean. I already have a terminology set. It means just what I want it to mean. And it's much easier for me to write a precise description of my architecture using the terminology that is precisely tailored for that purpose.
Fair enough.
I think what I heard Lou saying, among other things, was we have a terminology set that's really pretty close to what you mean, and if you use that, it will make the document a lot more accessible to a wider audience. So Lou is doing his email, so he can't say whether that's a good description or not. Anyway, and it seems to me like those are both good goals. It's obviously good for an architecture to be precise and unambiguous. It's obviously good for an architecture to be accessible to a new reader. And it furthermore seems to me that with anything complicated, the first time a new reader reads through it, no matter how precise you have been in your choice of terms, they're going to misunderstand something, because that's human nature. So it seems to me like one way of squaring the circle is, and I'm sure that this has been part of the discussion, maybe even right now, is to have a careful, exhaustive, and precise set of definitions, and to say, look, you can't really understand the document unless you have understood and internalized all the definitions and applied them as you're reading the document, right? So, you got to expand all the pound defines. Sorry to date myself.
I tried to do that, but I know I'm wrong already, so I have some changes to make. So, but at least I tried.
Right? No. And in fact,
path, there are big terminology sections explaining what they are, how they differ, in my view.
Yeah.
But I was wrong on something that Lou told us. So I know I have to fix it already, right?
Right. So actually, I don't mean this as a criticism of the document as it stands. I'm just sort of trying to set up one more thought, which is, once you've accepted that the only way that your document is really going to be properly understood is by somebody who has carefully read your definitions and is carefully applying them, then you can use either terminology set, right? You can use your native terminology set that you have been thinking in. You can use, what is claimed to be the more common IETF terminology set, which sort of the colloquial uses of it are, let's just accept for discussion that those colloquial uses are subtly wrong. But as long as that subtle wrongness doesn't lead the casual reader down a path to deep misunderstanding, I think it's okay, because the casual reader is just coming in and trying to get the big picture. And, sort of 1 in 50 casual readers are going to come back and read it 4 more times on their way to becoming experts. So it seems to me that, if you're going to bias towards one thing or another, it's maybe more valuable to bias towards making the document accessible and towards really focusing on, as you've done, towards focusing on using definitions to make sure that your meaning is completely clear. And I should have said up front that I'm, don't intend to be imposing any AD's opinion here or anything. This is just me sitting in the room listening. Thank you.
Yeah, so why I am so sensitive to not giving that wrong impression to the casual reader. The big thing, the way I see it works, right? Because it's not just the architecture. I have my mind image of what's exactly going to happen. What's going to happen is you've got this probably this PCE. I mean, the distributed is in the architecture as Lou pointed, but I don't have any clue of how to make that work distributedly. So say you have this controller, and the controller will observe the links every hop through a periodic statistical knowledge. So every hour, what's the ratio of delivery on that hop? So it's going to get statistical values because it cannot get so many full pictures of exactly what's going on. So it will have statistical views of all those links, right? And it will be asked to build something which allows every packet from A to reach B like 2.5 times. Every packet should arrive 2.5 times average, something like that. And you will say, okay, 2.5, if I just build 3 parallel paths with all the loss and the statistics, I get 1.1, which means that some packets would be lost. Not good enough. So let me build more of those things. Now, if I build too much, yeah, spectrum, energy, blood, that's why we're here. Okay, but the PSC cannot be that smart as to decide exactly on each packet which hops are going to be followed. So I need to hint, and that's the orient thing in OODA. I need to hint the PSC, if you see this, you do that. And each of those that is a subtopology of the overall thing. So the overall thing is all those extra links that the PC has decided may be used from A to B. The PSC doesn't just give that, it gives a set of T paths, each one mapping a certain condition of the network. And I'm willing to call those things T path, and I'm sorry I called that subtrack. And so now I have a clear usage of the term T path. It is this subset. Now, OAM doesn't care only on that subset because we are doing out of band OAM as well to see if there is another path in that bigger thing that we could use better than what we're using currently. Okay, so we need to observe the big thing that I call the track and use the sub thing, which I call the T path. You see? And so if I call the two of them the same thing, how can I say what I observe versus what I use? Now, back to Lou's point about, yes, it's just a service, the service. Actually, when I'm going to receive from the PCE all those different cases, I will instantiate a service for each of them. Because in runtime, I will just use one of those services, but in my code, I will have one instance, I will just say, flip that one on, flip that one off, as the immediate reaction. So each of the services, the blue, the red, the green, the whatever, they will be activated and deactivated dynamically based on OAM. That's exactly what's going to happen. So for each of those services, I will have a T path. So what I'm going to do is activate that T path, deactivate that T path. That's exactly what's going to happen. And then again, I need to represent the set of all those T paths. And what I call coalescence is when you observe all of them from above. And if you have twice the same link, it looks like one. But at the end, you observe the set of all that. That's the track. That's the big thing on which the PSC is operating from this A to B. And each T path is what one of the servers gives me, and I select which one I'm using. Confusing the two makes it very, very hard for me to explain exactly what I told you.
Thank you.
Kenji, China Mobile. I'm not sure I will be categorized as your carol reader since today, the first time I came over. And then the first time I saw your terminology track, it immediately comes to my mind the tracking narrator that being used since this is the raw, the radio, the wireless part. So that has a different meaning. Tracking narrator, okay. Probably talking about some set of cells used for switching, routing, but in the wireless part. Okay, and then I continue reading through and they talk about the 6 TI-SCH channel. And then, okay, so probably and then you say, okay, we're not introducing anything new. And then, oh yeah, okay, so probably for some base station, and then on that side, for the channel, you're talking about the DRB. And then I continue reading, and you say, okay, use statistically and combinational combinatory aggregation of the blah, 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 everything. And then at that moment, I said, okay, well, you are talking about the PSE and then going to determine a path. So for me, I have both background. When I read it, the first impression I got is a little bit confused. Yeah.
Can you help? I mean,
And then
basically my problem is that
with your
people
explanation, I fully understand. But you know, I have
yes.
background on both, and then the first time I got confused.
That's wonderful, because we are lacking this feedback, because everybody here kind of understands what we've been working on for a long time. And when I said that I made a rework to try to make the new reader's life easier, it seems that I'm not through yet. So if could you write down what you just said,
Okay.
and maybe suggest, you know, how things could be reordered, or where you had those times of confusion?
Yeah, but I try to ask you one particular question. When you talk about end-to-end, are you only talk about up to the base station and beyond on the layer 3 part? Or you're talking, since you're talking, this is the raw, the radio, the wireless part. Are you also mentioning from the UE all the way to the server, the whole path?
Okay, so there are two things here.
Yeah.
One of them is there are two use cases in RAW, because that's the use cases that were presented to us in live, and there might be a lot more to wireless than those two use cases. And you talk about UE and then base station, so that's use case one, when RAW protects the access, only the access, but it observes the end-to-end path. So basically you get feedback from the other hand whether the packet was received, but the only thing you really act on is the first hop. So if the server doesn't get your data over wireless Wi-Fi, you'll go to 5G, regardless if the problem is really with the Wi-Fi or if it is somewhere else, right? So that's when the OAM is layer 3, and the selection, the action that you can take is just on the first hop, because the rest you don't control anyway. So that's half of the discussion. And so the other half was what? Oof, I lost myself. What was the core of your question, please? I need to come back to
the
the
thing
screen.
here called the PSE. Okay, so from the IP and side, I understand it's like some place to calculate on the layer 3 the tunnel. But the thing here, if you look at the radio architecture, especially 5G, the layer 3 is you can consider on the GNOB side, and then so for your end-to-end path.
Yes, the PC discussion only applies to the second case in the architecture where you do the mesh. So I told you there are those two big use cases. One of them is we protect the access only, and even if the fault is not on the access, we'll switch the access. And the second use case is we have this mesh, and we are looking at a multi-hop wireless track. And that's when all this discussion that we had happens, where the PC will look at statistically blah and say, use that. Well, even on the first use case, the PC will tell you about the statistics of the links, but it does not compute the end-to-end path that we are talking about. It just says you switch this interface or that interface or that interface based on observable qualities or whatever. So if you see, for instance, that your Wi-Fi reports that the speed is this or whatever, you switch to 5G, just an example. That's the kind of reaction that the PC could tell to the end user, user equipment.
Let me just to make it very, very clear here. For your statistic terminology used for the track, suppose this is the radio, the 5G scenario. On the downlink from the G node B, here, when the downlink traffic come onto the G node B, it's going to select based on the some 5QI, it's going to select different DRBs, the data radio barrier. Okay, so that one is going to be, well, depending on the QoS profile that being set. That'll be the selection. Okay, well, it's not random, it's not statistic, but if the guaranteed bit rate will be selected, non-GBR is gettable something, it might not.
Yeah.
So for your statistic, and then my understanding is like their track is some sort of like statistic combination such that you flip the coin and then you do something.
The statistics in the access case, the statistics are obtained through the end-to-end OAM, and whatever the layer 2 does is not observed. Normally, it's not observable. We don't really have access to what layer 2 does.
Oh, okay.
So that is the use case where the OAM is layer 3 from the client to the server. And if that goes bad, we just switch the radio.
Okay.
But we don't know what bearer, we don't even care if it's Wi-Fi or 5G.
Okay, sure. Thank you. Because the first line just gave me the impression, because this one used the similar like the 60i SCH, and we are not introducing anything new. So, okay, I'll try to associate these two together.
But please keep in touch. Please keep in touch. I mean, anything that creates an issue for the reader needs to be addressed.
So I'm in the queue next, Rick Taylor, with chair hat off, really. Lou, it's kind of a follow-up question to a statement you made earlier, and I'm glad you're in the queue behind me. Going back to the track versus path question.
It's incredibly hard question.
Because we've got to get to the bottom of this. So actually, quick comment concerning John's statement. I'm in complete agreement that and this goes back to my idea that we are a sibling group of DetNet. So making sure that if you come from a DetNet background, you can immediately understand because there is commonality of terminology, but if specifics need to be pulled out in order to make a coherent argument, that's absolutely fine and should be front and center so that those differences can be noted. So my question to Lou actually was, given you have layers of service protection functions, and effectively a service protection function does something to paths or hops, you know, and it's going to be paths, I think, where a service protection function which does some sort of duplication and replication and elimination pairing. So that service function is creating, what do you call a link of service functions from end to end if a service function does something to makes choices between paths? What is that chain of service functions? Is that a service path? And I think
that did not exist in DetNet, not that I know of.
And I think that might be the crux of the problem, because we've got layers and we use the same word path for every slice through all the individual layers, some which may or may not appear at different points across the thing.
Yeah.
So we have a recursive architecture, not an overlapping architecture.
Okay.
Yeah.
So
recursive is fine. I agree with that.
So one layer can receive service from a lower layer, and it can provide service to an upper layer.
Yep.
Each of those are services. When you go to end, if you look at the architecture document, it says the end-to-end service. It's really simple.
Yeah.
And it's independent of how many services it traverses. It's still the end-to-end service, because when you're operating at a layer, you see what layer you're operating at. So switching, across the horizontal, providing service up to the vertical, where, when you're going up vertically, that's to the application. And when you're going down, you're receiving service from the network, usually represented as interface, but there's lots of ways to implement that. It's not standardized. So if you're talking about the collection of services that's used to deliver traffic to a DetNet application end-to-end service, it's in the architecture document.
Yeah, no, that is fine.
Agreed on all this.
Sorry, Pascal, that's absolutely fine, and I understand that. But what I'm saying is, as you start to talk about that from a technical perspective, and you start to delaminate across these recursively applied services, layers, if you're talking about a particular service function which says, there may be a service above me, there's almost definitely a service below me, it may just be forwarding, I have a pairing with, replication and elimination. You have a pair. One replicates, one eliminates.
Right, a protection domain. You have a protection domain.
So the relationship between those two, they exist within a protection domain, but the transit of packets from the replicator to the eliminator function,
yes,
does that have a name, or
is it's the end-to-end service at that layer? So remember,
no
it's a recursive architecture.
So these are
at a particular layer, if you are providing a service, it's your end-to-end service. To your application, it's not their end-to-end service.
So if I understand your argument correctly, and I think I understand what you're saying, but I'm trying to see if we can apply it. Could we just replace the word track with end-to-end service?
No,
Because we're talking about.
I really believe so. And to John's characterization of what I was saying, there's one additional point that I think is really the crux of where I'm coming from, is if we can figure out the aligned terminology, we can figure out what technology we can reuse.
I think that's understood.
And then what technology, what new mechanisms we have to define. Because I think there is something new here.
Oh, I think
It's not that
that's where we are. That's what
Right.
we need to do.
So what we want to do is tease down to what's new and then reuse as much as we can. And that's the whole concept that is embodied in Internet TE and TEAS and CCAMP and all that prior work.
Next.
And there's one additional point I'd like to make.
Yes.
This is a separate point. Well, actually, you're the one in queue, and I'm responding to you.
Sorry. Can
So
I make my second
when
point
you're
first?
done, I'll make my point.
Okay. So, oh God, you just interrupted me. So, and this is kind of a question to Pascal now. If you call it a end-to-end service at a particular layer, is that a pipe or is that still a flow? Because I agree with you on pipes. I actually do agree with you on pipes, and I know that's a DetNet consideration, not particularly a raw one. I think there's a big difference
Between
about
water and pipe.
defining
Yeah,
the pipes
I
and
hope we are
measuring
very-
the flow point to point.
Look at this picture.
Okay.
Hey, we spent some time yesterday on that picture. I'm sorry for the rest of the group. But I presented it at the last IETF. It's very hard to build. It's a very simple picture, but it's very hard to build. What it's trying to say is that the PSC operates outside of the flow of the packets. Remember, it's something which will switch from service blue to service red because the radio conditions somewhere have changed. And you could see it as a fork of packet, but no, because it's not in the data plane. That's my answer to you and Lou. That's why I say no. It's because this thing happens asynchronously to the traffic. This happens in this OAM plane, if we really want to have an OAM plane, where we will switch the service, but the next packet will only see one service. On the path of the packet, there won't be a service selection that will, and then a sub-service selection. The packet will just see blue service. It won't even know there was a red service.
Sorry, Rick, I completely agree with you. Go on, Lou.
So when you're switching between services, in the DetNet architecture, you're actually switching between forwarding paths. Because remember, it's recursive.
Yeah, exactly. It's what
so if I'm an application operating at whatever layer, I have below me, yes, different services. But then if I go below that layer below, each one of those is its own service. So I think you're saying you're not switching between services, you're switching between forwarding paths in the recursive architecture. I think it would be super helpful to draw the same picture for a wired network. We have a protection switching function defined for DetNet. We have one. The architecture allows any. So we could have a 1-for-n service defined in DetNet. We don't. We only have a 1+1. But that is a type of switching function. That's a type of PSE. Now, it's a very...
Sorry, no, I don't believe that is what Pascal is saying. I don't believe that's a PSE. I think a PSE is a purely control plane mechanism that decides what switching function should be applied.
You switch
There's
the
a difference
service
between the
under the carpet.
applicator and the function that is being popped in line.
And I hear you.
Yeah.
So in DetNet, it's a very rigidly controlled PSE, controlled by a Yang model, and it's expected to be driven by a provisioning system. But there's no reason that couldn't be driven by, take your AI ML system that automatically changes it based on what it sees as, the weather pattern of the network.
And you reach Roland when you do that.
Yeah. Or a thing called a PSE.
I'm sorry, I didn't hear what he said.
No, I'm saying, and that's this could be included in what we discussed. That's when you reach Roland, that's the extension we want to provide, or the additional refinement we want to bring to DetNet. All you're discussing, it's supposed to be this.
all of what I've just said is in DetNet today.
The architecture does not discuss it, does not prevent it. We want to put
I think
more
the
details.
Yang model fully supports what we've talked about. I think that the architecture defines it allows for different protection mechanisms. We've only defined one. We've always talked about we may be doing others. We identified network coding as maybe the second, but it's a maybe second. We're contribution driven. So if someone came with something new, we could talk about that. But I think from an architectural standpoint, you're not adding something fundamentally new. You're adding a new protection switching, which already fits into the
No, we are switching the protection switching under the carpet. That's what we are
great.
doing.
I'm just saying,
So we are
I
not
think it would be
operating
helpful.
in the same plane because we are doing it. That's why that picture is important. What you're saying is all true. But at the end of the day, how can we express in this document that we are not folding plane, we are not doing steps in the going through layers for the packet operation? There is only one layer. It's a service. Well, and then going down to forward. But we never go through the control layer for the packet processing, right? And we need to expose that to the reader.
Yeah. So I don't think we're arguing about the net effect and the behavior on the wire, right? We're arguing about how to represent it on paper,
Yeah.
so it's more accessible to the reader, as well as allows us to reuse existing mechanisms, documentation, so we can reference rather than have to define a whole new set of things. That's what we're really talking about, right? I'm suggesting take this picture, draw it for wired. However you see to do it, draw it for wired. And then next to it, say, here's how it's modified for raw. And I agree that we don't actually have this picture drawn for DetNet. Now, I did drop in chat something from a long time ago, which was MPLS TP, talking about how to do it for wired networks in MPLS. And remember, DetNet inherits all of that.
It was that much more refined.
So the point is that, or my point is that that type of thing exists for wired already.
It doesn't matter. I mean, yes, it does, and that proves that we are doing the right thing, right? But at the same time, we still need to show our readers what we are doing, even if it already exists. That's the other
exactly. But let's show it first for DetNet, so people can understand what is there already.
Can I
then add into it what is different.
Can I just interrupt for a second? I think we've started to move on to a PSE discussion rather than getting to the bottom of the track issue. Or do you believe that they are so intertwined that we need to continue this?
I was responding to the slide that was brought up,
fine.
And so
I brought it because I thought it was intertwined. Sorry.
Okay, that's fine. Sorry, that was chair hat on there, just trying to.
Because
I think they're separable, but he's the one driving slides. He's the one showing a slide, so I'm responding to the slide.
The reason why I think, and it's me, right? I mean, we are a room, so is that for me, all the T discussion works. So all the existing terminology we have in DetNet, and that relates to draw it for DetNet. If I was to draw it for DetNet, I would basically say, hey, we have some service access points here, and now we have a new client to the service access point, which did not exist before. But the service access point exists in DetNet, it's in the model, etc., and that's neat, that's perfect. Now, we have this new user, which is effectively not the one we expected when we wrote initially the architecture, but the architecture is open to having it. And now RAW is introducing that new consumer to this provider's app.
So you're actually taking me to the point that I wanted to come up and actually make my point, which is it's true, we have an architecture document. You wrote a lot of it, but what came through the working group is what the IETF agreed to. And I've had this said to me, by the way, for documents that I've written, is it doesn't matter what I wanted it to say. It says what it says.
Yeah.
So we have to accept that that's what the IETF standardized.
Yeah.
So, I've heard you say a couple of times, I know I wrote that and this is what it should say. Doesn't matter. It says it. And again, I'm saying something to you that was said to me previously as an author.
I take it nicely. I mean, no issues with that. It's just a matter that still the
whether
language
right
is what it is.
or wrong, that's what was standardized or agreed upon, because it's not a standard, it's an informational document.
Exactly like close, right? When you
and
read
if you
it after that, you might still understand the words in a slightly different fashion. So we might both think we agree with the architecture and we might still have a different image of what it is.
I agree with you completely. And that goes to the next point, which is different protection functions from my perspective as a reader. I don't think I was an author on that. I did comment a lot, but I don't think I was an author. I saw the ability to do any number of protection functions.
If you take
And
it very abstractly, we are on the same
That's how I
line.
read it. And that's, I saw that there was even multiple examples listed in the document. So the fact that you have another one which is interesting and tailored to a wireless network, that's great. It fits right in the architecture.
Okay, so where we seem to converge, at least I can agree with what you said, is this is a protection function. I agree with that. I don't agree that it is a service layer function, because the way we define the service layer, it's a forwarding plane activity. That's why I brought this slide. That's service. I mean, it's a control domain service, if you like, but it's not the services that we have today, because the only service that we define and where we placed it in the forwarding plane. And because this thing is in the control OAM or whatever plane you want, then it doesn't fit unless we take our definition of service and extend it to control plane activity. So that's the thing. But it is what you said. It is a protection service. It just doesn't live in the forwarding plane like the services do.
Go ahead, Don.
Hi, Don Fedek. I think that, like, you've spent a lot of time on this, but you've taken a step beyond what some of us can keep up with the new terminology. I would suggest, like, lose the term track and describe it in like you have the definition in terms of a path, whether it's an aggregated path or collection of paths or whatever. And let the working group decide if there's a term that we need to describe that in the end. And for a couple of the new terminologies, do the same thing. And that would add clarity to the document for me, because conceptually, I'm not jiving with it when I see a track, and I'm sure a few others have the same problem. But if we use all the same terminology that we've used before, and maybe it's a big bunch of words that we have to use for this version of the draft, and we would decide that we want a term that describes that, then I think we would reach a consensus on this faster.
That's very wise advice, Don. Thank you. I'm next in the queue, so I'm going to sort of go back to the argument, not the polite discussion between Lou and Pascal here. The splitting of the document, I think, was made to separate the Pareo service function from the PSE's role in the architecture, because I agree with Pascal here, they are two separate things. And I think where I disagree with Lou is I believe he's telling me that they're just one thing. That's what I'm picking up, Lou. If that's not what you're trying to say. As you said it, DetNet has their service control function, Yang models.
It's Lou Berger. You asked me, are they the same? I said, I think they're separate, and I just switched to it because he switched to it on his slide.
Right. Okay, fine. In which case, I withdraw my previous comment about my understanding of what you were saying.
It's Lou again. I should say, that's what I meant to say. I actually have no idea what I said.
Welcome to my world. Yeah, we'll consult the minutes. Fundamentally, there's the beautifully Yang modeled DetNet service control function or service control model. And as I understand it, the PSE can be a user of that in order to change service function based on some management and monitoring information that flows across the control plane, policy, whatever. That is a unique decision or a unique part of the raw architecture, because Pascal and the working group, by extension, this is a working group document, propose that fast feedback loop is important in order to supply deterministic services across wireless links. That is different from, by the way, we think we can produce a service function which will give you better reliability across whether we call it a path, a track, a stream, a flow, I don't care, within the DetNet service sublayers. And splitting those two documents may help clarify that. Does anyone disagree with me on that? Pascal,
No,
am I
no,
miles off here?
If I understand you well, like I'm not sure I understand my own words in the architecture, but if I understand you well, I'm with you.
Lou Berger, sorry I'm not in queue. I just went fast enough with the app. Um, your words just made me remember that we spent a huge amount of time going over these drawings of protection models as we were developing the Yang model to make sure we were appropriately modeling what the data plane could do. And Don was involved in that. I was seeing if Don had a pointer to any of those, but maybe we can grab those and give it to the working group here, and then we can start extending them to draw the pictures of what we mean. And then we can say, we're pointing right here, and this is the new thing, or we're pointing here, and this is the existing thing.
I think that would be very welcome, because both Pascal and I had a corridor conversation where we admitted neither of us like drawing ASCII art, and we both struggled.
No, these are PowerPoint. They're not
yeah,
ASCII.
But I bet we can find a tool that will turn them into ASCII. But anything to help with clarifying diagrams, I think we're so in the realm of a picture is worth 1,000 words here. So
Yeah, I'll see if I can dig it up, or Don will dig it up, and we'll send it to the list.
Since Lou, you brought up the Yang model, first thanks Don for the huge effort, and yeah, that's huge. I mean, I've not really contributed on the mailing list, but that's a huge thing. Now, a model gives you what you can use and not how you can use it. That is the architecture, which will tell you what you can do and what you cannot do. For instance, a model of a car will tell you that if you press the pedal, it's going to go faster. It doesn't tell you whether or not you go when the light is red or green. That's the architecture. And so because the Yang model is wide enough to do stuff, doesn't mean that we do all those stuff that the Yang model allows. What we want is the Yang model to allow everything we want to do. But it cannot necessarily be limiting to what we allow. So there is a role of the Yang model, and there is the role of the architecture. And the thing that tells you that if the light is red, you stop. That's the architecture.
So Pascal, can I reply to that? I think you're slightly mashing two concepts together there. What I meant to say was, in an architecture document, you can say there is this well-defined control path between the service control functions down to the services themselves. We are very lucky that there is a good quality Yang model that can describe that. And in the architecture, we can say, we are going to use this, it exists, and people familiar with the prior work will go, aha.
That is
good.
perfect.
I
was not responding to that because I agreed with that.
Oh, okay, fine.
I was responding to Lou saying the way the service is modeled in Yang allow the service to be kind of maybe a control plane thing. I don't know if that's exactly, if it does that, because I've not been in enough detail in this document, sadly. So for me, it's fine that if the model allows that, it doesn't mean that we use that. What we use is what the architecture says we use, right? Even if the model is, the model has to represent everything we could do, and the architecture says everything we do. Hopefully, the Yang model is a superset of that,
yeah.
and not a subset.
So, Don, are you still in the queue, or have you? Okay, I'll bin you out of the queue. Stu, you're in the queue.
Yeah, Stu Card, and I'm not sure which of my affiliations I want to tag on this. So I just like to give a perspective of a noob. I have attempted to parse the DetNet documents, and I have attempted to parse the raw documents. And despite what is obviously an enormous amount of work by both groups and an enormous amount of intelligence underneath that work, I find neither of them particularly accessible to a newbie such as myself. Okay. They appear to be things that probably can be read easily by someone who is involved in the work from the first and can trace its evolution, and not so easily read by someone who was not involved in the work from the first and is coming in late and trying to wrap his head around this. Okay. So from that perspective, I have some sympathy for what Lou is saying about trying to make them more accessible. On the other hand, um, I do like precision. And by the way, we already in IETF and even in IRTF abuse the word path. Okay. If you go to the mathematical graph theory, we have walks, trails, traces, circuits, et cetera, et cetera, et cetera. Right.
Took me a long time to find track. I went
Yeah.
through the dictionary.
Right. So, so to draw an example from a different area within IETF, locator, identifier, split, you know, there's HIP, there's ILNP, there's Lisp, and there's probably others, okay? And each introduces its own set of nomenclature, which on the one hand is annoying, but on the other hand, not only are they potentially attempting to address a different set of requirements, even to the extent that they address the same set of requirements, they may partition and allocate those requirements to different subsystems within the overall system architecture. And the use of the same term to refer to a box that over here on the left includes A, B, and C, and over here on the right includes B, C, and D, I think ultimately could be more confusing than attempting to reuse terminology. Thus, I come down on the side of introduce terms at will, be very precise in their definitions, but you know, there's a sentence that could go early on that could make this a lot easier. You could literally say in the raw document, this is what we really mean by track. But if it makes it easier for you on a first read to think path every time you see the word track, that's fine on a first read. But on a second read, it will be very important that you distinguish a track from a path.
Thank you, Stu. That's good advice.
I tried to do that. And actually, this discussion today clarified my own mind a lot. Even in what I don't even know I'm thinking, right? Because having to express it to you guys helped me sort out my own thoughts. But the reason why I brought this slide, the reason why I think it's entangled, it's because, in my view, what we call service and service layer is forwarding plane. Since PSC is control plane, I didn't see that as a service stacked over another service. And I completely agree with what Lou said about recursive, for instance, what we call compound flows. And for me, it's just tunnels within tunnels, kind of, if you want to visualize it. It's just a bigger pipe where you have smaller pipes in it. This is service between service because the bigger pipe has its own service layer.
And
So certainly you nest service layers when you do compound flows. You do that. But the operation, the packet sees that operation. The packet feels every of those operations. The packet doesn't feel the PSC. The PSC has been done under the carpet while the packet was not looking. Okay, and that's the reason why it's not forwarding plane, and that's the reason why I don't call it service. Now, if we decide that we have control planes reliability services as well as data plane reliability services, all of a sudden we agree, right? So my question is really what we define service layers. Oh, it's right, but I want to be honest to this drawing. And then again, it looks simple. I mean, Lou's drawing on MPLS was very, very complicated, but making simple is hard, actually. And I spent a lot of time making that simple thing out of the much bigger thing with a lot more stuff in it, which looked so intelligent, by the way, but.
So, Jusant, I think. Sorry, I'm terrible with pronunciation. You're in the queue. Go ahead.
Hi, this is Xusong. Pascal, thank you for your explanation. Just because as the co-author of the Dan and Young model, I just want to ask some clarification questions to make me more clear what you try to describe about the PSE. I just read through the document about the concept and the description. Does it mean that is a control loop? Does it mean that the PSE itself includes the OAM process and the controller plan process and also the maybe something like forwarding plan or service layer of the net?
No,
It's the combination? No.
the PSC is this little box on the top left of that screen. And the PSC talks to somebody who represents what OAM finds, which I call the OAM supervisor or something, just that thing which sits in the control plane that observes the OAM activity and gets reports from OAM activities. So it knows something happened on the other side of the network. Now PSC needs to take action. So PSC is just this, and it's written, you know, if you look at the UUDA, again, that's why I like this UUDA reference model. It's because the PSC is the one that does the decide. The PSC decides, right? But the U, O, O, and A are done by other nodes, other components on this of this control loop. The control loop globally is abstracted as these 4 letters, UDA, and the PSC is the D.
If it helps, I like to think of the PSE as a small, stupid, local PCE.
Yes, it's an extension of
It
the
may not be
PC
small
for-
or stupid, but it's probably quite local. I'm working on a fast loop.
In the initial view, we'll make it very stupid. I have ideas on how to make it more distributed, in which case it could become a bit more intelligent. But for now, see it as a source-routed, multipath type of activity.
It seems to me like PSE is part of the control loop, and it is kind of the connection between the OAM and the forwarding plan.
Yes, OAM is the observe, the O in UDA.
Yep.
And it does the decision kind of like PCE.
Yep.
Yes.
Okay, I try to understand.
The PC is the orient, and orient is the only letter that is intelligent in the EUDA loop. Orient is the one that has some historical understanding. For instance, the statistics that we bring to the PC, so it knows this link is feeble, this link is solid. So when I construct those alternate paths, I will rely more on this one than on that one, and expect that this one fails, in which case I've prepared this plan B for you, which is service red.
Okay, thank you for the explanation. I think I understand it more, but I think I should take more time to think about how to connect
Model.
the concept in RAW with the existing terminologies or concept in .NET.
Can I ask, when you do that thinking, can you
after this meeting?
No, not now, but over time,
Uh-huh.
if you find areas that you find difficult to make that thinking coherent and understandable for yourself in the document, please record the pieces and get them on the mailing list, because a document that isn't as easy as possible, given the technology, to help people do that thinking and get correct needs to be better. So you are a perfect reviewer because you are trying to understand it for a reason rather than just for interest. So that would be really helpful.
Thank you. I will try.
And Shusong, many thanks for, and Dan and Shusong for the hard work on the Yang data model. I know it's very hard to do right. And
thank you. Also, thank you for your work in RAW.
Yeah, it is.
Just try to get it clear, since Rick said this like a workshop discussion, so just keep asking. The more I listened, the more I got confused. Sorry about that. Because no, and not try to downplay, but try to just some clarification here, because I do both work on the wireless and wireline. Especially here, you're talking about like the path, the track, and then PSE here. So and also you mentioned for your wireless, I think you mentioned about something like from Wi-Fi switch over to 5G. At one moment you mentioned, but I try to map the 5G architecture through the 3GPP access and the non-3GPP access, including your Wi-Fi. And so here your path. Let me make it clear. Is your path the data network path beyond N6. It all is your path, including the backhaul path between the G node B and the UPF. All is your path end to end from UE up through the backhaul, through the 5GC, and then all the way beyond the N6, including DNN. So just try to get it clear. Thank you.
Can you, oh no, we don't have it. Can you scroll rapidly? Maybe we have that slide, the one which shows the two use cases. I want to be good. Well,
Which way?
no, oh, we're close. So go down, go down, go down. Up, I think it's, no, oops.
This one? Loose one?
I think that's the one. Okay. So what you see here is probably the drawing that corresponds the best in the document to the situation we are talking about. So the situation we are talking about is we don't have an end-to-end service. We don't have end-to-end visibility on the path. The only thing we see is what we see at layer 2 and what we see at layer 3. And in the case of 5G, because now you're modeling the 5G network as a deterministic TSN type of network, we could say that the DetNet forwarding extend to the G node B, basically, E node B, whatever it is. So this relay node would be the end of TSN, quote unquote. The 5G network.
I've got a pointer. Here we are. Pascal, can you come back to the mic? See what, I think there's a laser. Yeah. The little red one.
So the point I was making with the two use cases is this is part of the use case A, where we only protect the access. We don't know how you build the network behind it, and even TSN doesn't see it, because TSN at least talks to your whole 5G network as one switch, but we don't see what's inside. We don't have visibility. So the bottom line is we have layer 3 OAM, so we can observe when we send something, whether it's received. But we don't know what's going on here because it's completely opaque. It's the internet, it can be anything. And so we cannot take actions that happen here, like inside your core. We don't see it. The only thing we see is when we send a packet, or we send OAM packets over this interface, whether they're received or not. So see the OAM activity in my phone as being, oh, I've got those 2 or 3 interfaces on my phone. One can be 3GPP, there can be 1 or 2 Wi-Fi, there can be Bluetooth, whatever. I've got those interfaces. And I'm sending OAM packets on all of those out-of-band OAM packet on all of those interfaces. And I'm trying to measure if some of them reach my server, reach the other end. And based on that, I can make decision of whether I'm using 5G, Wi-Fi, or whatever else. From the abstraction that we live on, we don't even care what type of radio that is. It's just access A, access B, access C. And if I send a packet on access A, access B, access C, I'm getting this sort of reliability. Should I use 2 of them? Which 2? Should I use 3? That's what the PSC will decide. That's all it will do. It doesn't have any control, visibility of the type of radio or anything.
So, sorry, can you take it to the microphone? Yeah.
So when we know the track is the other use case where it's a mesh.
Okay, so it seems to me you try to make the 5G system as a black box. And
It is.
Yeah.
You do not care about the backhaul, but also running on the IP.
Yes, we see end-to-end IP and one hop radio. Like if my 5G goes down, that I know. But the rest, I have no visibility on it. So I don't act on it. Yeah, so all this discussion is kind of out of scope of all you're asking.
Okay.
Chair hat on. Later, once we get the architecture and these core documents done, having there are link layer protocols for some types of radio, having an ability to understand better, to get better OAM from those lower black boxes, so to make them gray boxes in some way, that would be very interesting and can provide more information on that OAM flow so that we can make smarter decisions. That's a good thing. So they don't have to be black.
Okay.
But in general, you have to assume they are black boxes
To start
until
with.
we can find some way to get information out up first, and then maybe later down. But that's a part 2, part 3 of the
Okay,
problem.
sure.
So
Thank you, Rick. And
Yeah.
now, you know.
The more deep type of stuff we get, the best our life, certainly.
Okay, sure.
Yeah, we're genuinely trying to do step 1, then step 2, then step 3. It's thank you. Lou, you're up. Thank you, Pascal.
The queue's too long. I forgot what I was going to say. Sorry.
In which case, Don.
Well, we still have 10 minutes.
Yep.
So.
When you were talking about the PSE, did I hear you say that the PSE is deciding like locally to optimize for each service? Is that what it's doing?
Yes, it is. It is switching which
Okay.
service is being used for that.
So, and what makes that stable when everybody's trying to decide optimally for themselves? Like what coordination function makes that stable?
Okay, so in the current model, there is only one place where that this decision is made. It's the ingress of the track.
But it's every service making its decision for itself, right?
Oh, you mean I have multiple services that I run in parallel? That's what you.
Well, they're all over the network, right?
Because we. Okay.
Or it's just
Oh,
one.
all over the network they're nested, so you don't. They will all depend on what's going down below. Yeah. So the intelligence behind all this is the PCE. But if you do this recursively, I mean, each of the nested levels will have to offer an abstract reliability level between ingress and egress. And if that's used as one hop for the inner flow, well, the goal is basically this, right? You've got in and out. And for one in, you want 2.5 out, something like that, just to ensure that your loss is 10 minus 5 or 10 minus whatever. So you should average 2.5. It's just a number I'm giving. Now, if you say, hey, I'm going to do compound flow, and between here and here, I have yet another track. Well, this other track will be abstracted as something which gives me 2.5. And so that's the PC doing this, right? It will build this inner track, get to 2.5 out of it, and compute that this is a virtual link now that has 2.5 and make the bigger end-to-end service for the inner flow using that 2.5 link. That's how I visualize it.
When you say 2.5, that's like on average.
2.5 copies of the packet reaching the destination. So you
But
eliminate.
there are
average 2.5.
multiple things that are trying to arrive at their whatever their optimal number is independently.
Yeah.
Yeah. I mean
That
can be a problem. It can be a problem.
The PC is supposed to orchestrate all this. If it has more than one service,
Right. So
it
then
has
there's
to provide
hysteresis.
directions. There could be a meta PSC playing with all the PSCs.
Well, then they're not independent. There's hysteresis and there's
Yeah.
global coordination then, right?
I did not visualize it with multiple services like this. It's just blue is a set of things, but then you select blue as a whole. I did not think you would select some little bit of blue and some little bit of yellow. I thought that blue would be a consistent set of activities. And it's not like you have multiple of them which operate independently. It's just the set. It's the parameters of your pre-auth in that node is in blue, and there is another set of parameters of that node that is red. But I did not expect there would be parallel sets doing different things which are talking to one another. It could get crazy.
I think if you were going to do that, you'd use the layered service model and either put that as a layer below or a layer above to do that multiplexed stuff.
I
That's the only
agree.
sane
It
way
could
in
get
my mind
crazy.
to
I
do
just
that.
don't have a
Rick,
good
sorry.
answer. I never figured you could run two things in parallel on the same packet without knowing what you're doing on each side. That looks crazy to me, even if we don't switch services. But
okay,
because if they all have, if you can't do two control loop on the same physical system, right? I mean, even in the real world, if you have something that decides if your heating system goes up and down, and another thing that makes another decision for the same heating system, you have a problem.
No, but even if you just have parallel ones, each with their own PSE, they're going to compete with
on
one
two
another.
on two different flows, right? Not on the
Yes,
same flow.
yeah.
Oh, on two different. Oh, so you mean physical resources somewhere in the network?
Yes.
Okay,
yes.
okay. That's classical NetNet. You must ensure that the physical resources are available to your flows.
So I've locked the queue because we have 6 minutes left. Lou, you have just squeezed in. Can you keep it short, please? Just
Yeah, this is a question to the chairs. Can we ask to get a sense of the room of whether or not we want to, going back to what Stu was saying, do we want to focus on new terminology that may be more precise, or to try to leverage existing terminology and then refine that?
And if I may tweak the question a little bit, remember that on the table, there is the third, the in-between thing, where more of the existing terminology will be anyway injected in the document. For everything which is a term subtract will go away, basically. It's going to become anyway a path. The question is for the big track itself, right? For the rest, you won already.
so yes, that's a good suggestion. I'm just trying to work out some way of asking that question using the show of hands tool.
I'm clear that I asked it very badly, so don't use my formulation.
I couldn't come up with anything better off the top of my head while you were.
So I would like to point out that this week I've seen various things that went poorly because the show of hands tool is a blunt instrument. Unless
Yeah.
you think it through beforehand, you end up getting bad data out of it.
Yeah. And really, we want to censor the room. Does anybody object to what I think my understanding of the room is? I think I heard strong consensus that people wanted a terminology section which unified familiar topics for people from the two main inputs, from the wireless world and from the DetNet world, and added some richness to say, in this document, when we talk about this thing, and I liked Stu's words here, we mean something like this, something like that from the other world, with some qualifiers, and getting that in early, section 3 in that document, just to aid the reader. Does anyone think that is a fundamentally bad idea? I thought that might.
That one is a consensus.
So my following question is, given Pascal is not a native English speaker, and this is very much about, and I'm going to say US English, because British English doesn't help sometimes, is there a US English speaker who would like to contribute text to this? And I'm not saying that there are great people who speak English with a second language, and so I'm not going to discount them. But given we are spending a lot of effort on the nuance, and I'm using a French word, of this terminology, I think we need help on this. Is anyone willing to step forwards and do this? I see Don Felix's hand. I'm saying that for the record. Yes, and I will absolutely underline that point. You're correct. You are correct.
This hand is halfway up because I'd be thrilled to review and help tweak, but I'm the wrong man to help draft.
That was Stu Card saying he'd be thrilled to review and help tweak, but he's the wrong man to draft. Right. Thank you, Pascal. You can. Oh, and Balash as well has raised his hands, which is fantastic. Great. Thank you, Pascal. Do you want to add any last points? Otherwise,
I just have one last point, is because you said something at some point. No, I did not want to interrupt the discussion on that, but it raised the image that people might misunderstand something. And that something is, some protocols are based on sessions. There is one endpoint which does something, the other endpoints that has to be aware of it and does, the matching thing. The pre-auth doesn't work like that. For instance, you might have one replication point that makes 2 copies, and later on the right, there may be another replication point that makes 2 copies. Somewhere in the end, there will be a single elimination point which will eliminate all the copies. That single elimination point doesn't talk to either of the other two. They are independent. And it doesn't care whether those replication nodes succeeded. There is no session. So at some point, there was this image like, oh, if I make a decision on my hand, I have to tell somebody on the other end of the network because that impacts him. No, they must be independent. Because there is no time to talk to him anyway. Whatever we do, he needs to absorb. We can never negotiate. And the design, even the design is distributed. The operations can happen anywhere. And the nodes which absorb the copies don't have to know who made those copies.
Perfect. Thank you, Pascal. So we are very, very close on time. First, I want to apologize for the fact that we missed the 2-minute silence because we were too excitedly talking about things. I can only apologize to those who wanted to hold that. I'm so sorry. Any other business? Does anyone have anything that they wished they had talked about not concerning the raw architecture draft? So, well, there's our silence. In which case, it really, even I say thank you very much. That was a productive conversation, a good workshop in quotes. I think we have a clear way forwards. Thank you all for your contributions. Can you please maintain the momentum on the list so we can just get on and get this raw draft, this raw architecture done? Because we're going to start getting very sick of it.
I'd also like to thank those of us who've been heads down on the note taking, because it was a really dynamic and nuanced discussion. We will no doubt have to consult the recording multiple times, but thank you for the group of people who've been note taking, and please put your name into the notes that you were part of this.
And one last thing, thank you very much to everyone involved with getting LDACs out of the door. That was surprisingly painful, and behind the scenes, a lot of work happened. So congratulations for getting it kind of out of our hands. And thank you for everyone who helped make that happen. And that's it. Thanks, guys. End of the last session. Go have your extra side meetings and check out of your hotel room, which is on my to-do list. Otherwise, thanks, guys. Thank you, Eve.
Thank you.
And then I take it for granted that now we're working together.
Yeah, on that terminology section, definitely. To be honest, I don't care if you call them variables A, B, C, and D. Just define what those variables mean. If you go to it, I think you just need one of those.